Hello, this is Group C consisting of Joydev, Debnath, Supratik Das and Bhawna Kumari, and we welcome everyone to our final year BTech project presentation, done under the supervision of Professor Kandarpa Kumar Sarma Sir, Department of Electronics and Communication Engineering, Gauhati University Institute of Science and Technology. The title of our project is Low Cost Vitals Monitoring Wearable for Frontline Workers. Here is the outline of our project presentation that consists of introduction and theoretical background, literature review, motivation, problem statement, problem formulation, work methodology and approach, work done, experimental results and discussion, conclusion, future direction, Gantt chart and reference. So let's start with the introduction and theoretical background. The whole world is going through a very critical situation since the recognition of the novel coronavirus. And as we know, the World Health Organization declared COVID-19 as global pandemic on March 11, 2020. First human coronal viruses was identified during 1960s from human nasal secretion. And as we can see in the diagram that the targeted site is primarily the both upper and lower respiratory tract. Here is the another diagram that shows us the symptoms that may be present in affected person like fever, chills, lack of smell and taste, muscle pain, vomiting, etc. The epidemic of unknown acute respiratory tract infection broke out first in Wuhan, China since December 12, 2019, possibly related to seafood market. Based on virus genome sequencing results and on evolutionary analysis, bats has been suspected as natural host of virus origin and might be transmitted from bat via unknown intermediate host to infect humans. Bats are the reservoir of wide variety of coronavirus, including 3 severe acute respiratory syndrome. This severe acute respiratory syndrome binds to the host cells receptors angiotensin converting enzyme that is a critical step for virus entry in our body. And thus the chain reaction starts. It spread from one human to another and the whole world get affected. Here is the first 4 genera of coronaviruses. Coronal viruses are large family of viruses. Novel is the new strain of COVID and it is common in animals, but it has never been seen earlier in human beings. A wearable device is often used for tracking a user vital signs or data related to health and fitness, locations or even his or her biofeedback indicating emotions. Wearable devices modules may rely on short-range wireless systems such as Bluetooth or Wi-Fi setup. As shown here, example of wearable device includes various types of computerized wristwatch such as Apple iWatch, fitness tracking device, and revolutionary Google Glasses. Some issues around wearable device include privacy. Wearable technology is evolving into an important category of Internet of Things, with life-changing applications in medicine and other fields. The number of connected wearable devices worldwide has more than doubled in the space of 3 years, increasing from 325 million in 2016 to 722 million in 2019. The number of devices forecast to reach more than 1 billion by 2022. The advancement of wearable and growing demand from consumers to take the control of their own health has influenced the medical industry. The outbreak of COVID-19 crisis has expanded the role of wearable. The sample report here includes market data analysis and shows that with time its popularity is increasing among healthcare and fitness trainers. Here we can see the graph is increasing and we can conclude that the demand for wearable technology in health sector is also increasing. The wristwear product segment led the technology market, accounted more than 45% revenue share in 2020, and many more startups are gaining profit by building wearable technology, and it is estimated to grow from 20.2% to 22.8% from 2020 to 2024. These estimations are of wearable users' growth. Role of sensor fusion in IoT. Our project is based on IoT, and as we know, it is rapidly growing network of connected objects that are able to collect and exchange data in real time using embedded sensors. Sensor fusion is the ability to bring together inputs from multiple radars. In the field of IoT, sensor fusion is detection of external information, replacing it with signal that human and machines can differentiate. Thus, sensor fusion enables context awareness which has huge potential for the IoT, and these sensors even detect information required for smart devices from the environment. Here is an example of a gaming platform that can detect emotions electronically by monitoring data from physiological variables like muscle relaxation via pressure sensor, heart rate via ECG on chip. Smart devices thus help to monitor healthcare of human beings. In a cloud-based system, sophisticated big data algorithm can be leveraged to provide a more response to the gaming scenario. Here, sensors cloud even help to detect emotions by measuring the way a user holds a cell phone. IoT is a sort of universal global neural network in the sky that will touch every aspect of our life. From technology perspective, the IoT is being defined as smart machine interacting and communicating with other machines, object, environment, and infrastructure, resulting in volumes of data generated and processing of that data into useful actions that can command and control things and make life much more easier for us. Sensor fusion along with embedded processing and connectivity enables context awareness to provide us new services. Context is a circumstances or fact that form the setting of an event. Literature review. In order to make an in-depth analysis of project related to work done previously, all the project reviews was done before the project to enhance knowledge. These are literature review of our project we have completed that helped us to approach with the topic. We reviewed a good number of articles and paper related to our problem statement and found that recognizing the vital symptoms is the first step towards diagnosing medical problem. Moving on to the next slide, motivation. What motivated us is that wearable devices are efficient in providing remote monitoring and timely medical care. The pandemic has stressed the urgent need to adopt such kind of smart technology, thus reducing the contact between the patient and the health worker. And it is capable to detect vital signs like heart rate, body temperature, SpO2 level, respiratory rate, etc. Measuring of respiratory biomarkers are likely to have high information yield. Next, problem statement. Our main challenge was to design a device which should be compact as well as easy to be used by all age groups. Also, the integration of a breathing sensing system was a bit challenging. Further, to design the system in such a way that it can be networked via Node MCU using ThinkSpeak IoT. There were some problems identified during the project working. Primarily problems like with the temperature sensor, pulse sensor, and heart rate sensor due to some environmental factors. The problem statement comprises of two phases. First part that we have done in the previous semester, which was based on health monitoring system. The second phase was IoT-based smart wearable to monitor vital symptoms was completed. Problem formulation. In our project, the main problem formulation includes to measure symptoms using available sensors, to use basic ideas like measuring system, integration, digital signal processing and networking, all accompanied with basic healthcare knowledge, to design smart device that can keep track of the symptoms, to design the wearable technology that will be very easy to use by all age groups, to implement a breathing sensing system to detect respiratory rate. Lastly, to design the system in such a way that it can be networked to cloud for storing and monitoring the data.
So here I am going to present work methodology and approach up to the block diagram of our proposed prototype system. So in our work approach, our project phase 1 includes designing of an IoT-based health monitoring system, and it is based on wearable technology, which provides us the ability to monitor our fitness level and our health status. Here we are using Arduino, which is the brain of the project, and it collects real-time health data from pulse sensor, and it measures heartbeats in BPM, that is beats per minute. We are using a general purpose waterproof digital temperature sensor to measure body heat, and it is connected to Arduino. We are utilizing 5V DC buzzer to detect heartbeat rhythm, just like in hospital rooms where beep sound can give a healthcare professional to find an insight about pulse of a patient. Slow beeps indicates that patient is sleeping or in coma, or fast beep indicates that the patient is in some health trouble and needs immediate medical attention. A generic ESP8266 IoT module is connected to Arduino via UART, that is Universal Asynchronous Receiver Transmitter. It is used for serial data communication and is responsible for connecting the system to internet. Also for sending health data to IoT server for storing and monitoring. The circuit is capable of showing real-time data on LCD display. So moving on to the next slide. For project phase 2, our main aim is to design an IoT-based smart wearable watch, which is built around ESP8266 and it is derived from ESP12B. As soon as the watch turns on, the microcontroller fetches the data from the internet and displays it on the watch, which is very accurate and always up to date with the internet time. For it uses a protocol called NTP, which stands for Network Time Protocol. After that, it starts collecting the real-time data from the heart rate sensor and digital temperature sensor, which measures heart rate in BPM, that is beats per minute, and temperature is in degrees centigrade. Here a temperature sensor is a device which is used to measure the temperature. Similarly, the heart rate sensor, which measures pulse waves, which are changes in the volume of a blood vessels that occur when the heart pumps blood. After that, the data shows on an 128x32 OLED display. The smartwatch is powered by a 500 mAh 3.7 volt LiPo battery, which is connected with TP4056 onboard charging circuit. It protects the cell from over and under charging. CP2102IC is an USB to serial converter. And here SPX3819 is a positive voltage regulator with a low dropout voltage and low noise output. And finally, with the help of ESP12B, which is responsible for connecting the system to internet, after successful connection, it sends the health data to the Firebase real-time database every 1 minute for storing and monitoring. So moving on to the next slide. For breathing sensing system, the belt system has been created, which is having custom-made sensor of piezo, which is to be wore on the chest. A piezoelectric sensor is a device that uses the piezoelectric effect to measure the changes in pressure, acceleration, temperature, strain or force by converting them to an electrical change. The custom sensor will flex according to the inhaling and exhaling of the individual. The belt is powered by a 9-volt battery, which is having a voltage regulator AMS1117. It is a popular SMD package 3-pin voltage regulator that is available in many models for fixed and adjustable voltage requirements. And finally, with the help of Node MCU, which is a low-cost open-source IoT platform, the electrical signals sent to the Firebase every 1 minute. To access all the data in user-friendly way from the Firebase, we have created a website using HTML, CSS, and JavaScript, and also hosted it on the Firebase. So moving on to the next slide. This is the general diagram of the integrated system in the phase 1. Here we are using pulse sensor, temperature sensor, and buzzer, and Arduino Uno. Interface with 16x2 LCD display. Then with the help of UART, the data goes to ESP01, ESP8266. Then the data sent to IoT server, that is ThinkSpeak, for storing and monitoring. This is useful for a healthcare professional who is actively monitoring a patient on site. Here pulse sensor is an inexpensive analog sensor which can measure reasonably accurate pulse rate of human heart. With the help of microcontroller, it can operate from 3.3 volt to 5 volt. It has 3 pins, VCC ground and signal analog out. For temperature sensor, we are using general purpose waterproof digital temperature sensor to measure body heat. It has 3 wires, VCC, ground and data. For buzzer, we are utilizing a 5 volt DC buzzer to detect heartbeat rhythm. The DC buzzer has polarity positive and negative. Negative is connected to ground and positive is connected to digital pin 8 of Arduino. Arduino Uno is the brain of our project. It is responsible for collecting, displaying and sending the data to ESP8266. An LCD display is provided to see the real-time data from the sensors. The ESP8266 Wi-Fi module that can give any microcontroller access to Wi-Fi module. ESP8266 IoT module is connected to Arduino via UART, that is Universal Asynchronous Receiver Transmitter. It connects machine to internet and sending health data to an IoT server, that is ThinkSpeak, for storing and monitoring. This is useful for a healthcare professional who is actively monitoring on site. So moving on to the next slide. Here, this is the general diagram of the integrated system in phase 2. The diagram is divided into 2 sections. The left one describing the watch, the right one describing the belt. As you can see that we have used various sensors like temperature sensor DS18B20, which is one type of temperature sensor which measures temperature and it supplies 9-bit to 12-bit readings of temperature, and heart rate sensor which measures our heart rate in BPM, that is beats per minute, using an optical LED light source and an LED light sensor. Then the data goes to ESP12B from the temperature sensor and heart rate sensor. And after that, the real-time health data shows in the 120x32 OLED display. Here the TP4056, which protects the cell to over and undercharging. And the SPX3819 is a voltage regulator. Through CP2102, which is an USB to UART controller, it interfaced with the ESP12B. And finally, the real-time health data with the ESP12B, it goes and stored there in Firebase real-time database. For better accessibility of all the data, we have created a website using HTML, CSS and JavaScript. In case of respiratory belt, the belt is powered by a 9-volt battery followed by a voltage regulator, AMS 1117, which is an adjustable and fixed voltage regulator. The belt uses a custom-made piezo sensor, which uses the piezoelectric effect, which converts physical into electrical signals, and the electrical signals sent to ESP8266 Node MCU, then to Firebase every 1 minute. Moving on to the next slide. This is the flowchart of the proposed system. Initially, when the microcontroller is turned on, the sensor, that is the pulse sensor and the temperature sensor, start collecting the data. When they are attached to a patient or an individual, according to the algorithm, the heartbeat is in BPM, that is beats per minute, and temperature is in Celsius. Both the values are displayed in the LCD. Also, it sends the data to the ThinkSpeak server. The IoT dashboard is made accessible for everyone to actively monitor a patient or individual health data. So moving on to the next slide. So this is the flowchart of the proposed system in phase 2. Here the flowchart is divided into 2 sections. The left one describing the flowchart of smartwatch and the right one describing the breathing sensing system. For the flowchart of smartwatch, as soon as the watch turns on, it is connected to Wi-Fi. If it is not connected, then we have to check the conditions again. With the help of internet, the watch fetches the data and displays on it, which is very accurate and always up to date with the internet time. For this, it uses a protocol called NTP, which stands for Network Time Protocol. If we pressed the menu button, then it shows the temperature, SpO2 and heart rate. The menu button will slide the content of the sensor data to the main display. If everything is satisfied, the data is sent to the Firebase real-time database every 1 minute, which can be seen in Firebase dashboard, getting updated in real time. As far as the build, after the microcontroller is on, it is connected to Wi-Fi, and if it is not connected, then it checks the condition again. If the condition is satisfied, then it starts calculating the respiratory rate by inhaling and exhaling of the user. Then this inhaling and exhaling is converted into electrical signal and sent to microcontroller. Then further, this data is sent to the Firebase real-time database and gets updated every 1 minute. So moving on to the next slide. This is our block diagram of the proposed system in phase 1. The proposed design of the IoT-based health monitoring system is built around Arduino microcontroller, which is the brain of the project. Arduino collects real-time health data from pulse sensor, which measure heartbeat in BPM, is beats per minute. A digital temperature sensor is connected to Arduino, which measures body temperature of the patient. A buzzer produces auditory beeps. When the patient heartbeat is detected, this gives a brief insight to a healthcare professional. A generic ESP8266 IoT module is connected to Arduino via UART. It is responsible for connecting the machine to internet and also for sending health data to an IoT server for storing and monitoring. This circuit is not only capable of sending patient health data to a server but also can show real-time data on 16x2 LCD display. This is useful for a healthcare professional who is actively monitoring the patient on site. So moving on to the next slide. Here this is our block diagram for the proposed system in phase 2. The temperature sensor and heart rate or SpO2 sensor takes the real-time health data and displays it on OLED display. TP4056 helps the battery to charge, and it also protects the battery from overcharging so that it won't get damaged. Here the voltage regulator provides us the steady, constant voltage supply. After that, through USB to UART controller, that is CP2102, it goes to ESP12B MCU. And at last, the real-time health data stored in the real-time database, which is Firebase. For belt, there is a 9-volt battery which powers the whole circuit, and having one respiratory sensor. Through Node MCU, the real-time data sent to Firebase and get.
Hi, this is Supratik Das. Let's have a quick look into the work done so far. In the phase 1 of our project, we have developed a simple health monitoring system based on Internet of Things. So as we can see on the right, we have the overall circuit diagram for the work done in phase 1. In this design, The primary sensors include the waterproof digital temperature sensor DS18B20, the pulse sensor XD58C. There are two open source development boards used, namely the Arduino Uno and the ESP826601 Wi-Fi module. Other components such as the LCD display has been used to display the real-time health data, that is the body temperature and the heart rate. The buzzer beeps with the heartbeat or the pulse. The programming for this design has been done in the Arduino IDE itself. ThinkSpeak is an IoT analytics platform service that allows us to aggregate, visualize, and analyze live data streams in the cloud. FreeZing is the software used for designing the schematic of this particular work. Moving on. So we are able to see a setup for programming the ESP01 module. We have actually removed the microcontroller from the Arduino Uno board and used it for the USB to UART communication, since the Arduino Uno board has a CH340 chip inbuilt converter module on it. In the second phase of our project, we have developed an IoT-based smart wearable to monitor the vitals of an individual, which can actually help in the detection of preliminary symptoms related to COVID-19. The smart wearable consists of a smartwatch which can detect the body temperature, heart rate, and SpO2 level of an individual. We have also integrated a breathing sensing system to detect the respiration rate as well. If we can detect all these symptoms precisely and found out to be abnormal, we can say that there are some preliminary symptoms related to COVID from our existing healthcare knowledge. But we are not confirming it, and it can be taken as a warning of the health status. So, in the smartwatch, the primary sensors include the digital temperature sensor DS18B20 IC, the DF robot gravity heart rate sensor. Uh, the smartwatch has been programmed using the Arduino IDE, Microsoft Visual Studio Code, and the Platform IO IDE in the VS Code itself. KiCad has been used as the schematic software for designing the setup. The health data will also be displayed in the graphical user form in the website hosted on the Firebase. Now coming to the breathing sensing system, the primary sensor include the piezoelectric sensor here, which is a custom-made sensor with some rubber bands and a belt. Moving on. Here we can see the hardware integration or the sensor integrated system of the smartwatch. The ESP12V has been interfaced with the temperature sensor and the heart rate sensor, that is the additional sensor here. A menu button has also been introduced to shift the display, as it can display both the current time from the internet and the health parameters. The current time can be displayed using the protocol named NTP, which stands for Network Time Protocol. Next, we can see here the connection diagram of the OLED display, then the micro USB port, which has a common connection with the ESP12V, as well as the OLED display. As well as the OLED display is connected to the ESP12V, and there is a voltage regulator which converts the 3.7 volt to 3.3 volt. Moving on, we can see a CP2102 IC programmer circuit. The CP2102 IC is a single chip USB to UART bridge controller. This has been used altogether with the ESP12V to program it. Next, there is a LiPo battery charging circuit TP4056 IC, which protects the battery from completely discharging and overcharging. Next, moving on. Here we can see the integrated system for the respiratory belt. It consists of an ESP12V interface with the piezo sensor, and the ESP12V has been powered by a 9-volt battery, which first of all gets converted into 3.3 volt by a voltage regulator. Moving on, also design a PCB layout for the smartwatch since we need to consider it to be a wearable design. So here we can see the top view of the PCB and the bottom view of the PCB. So this is actually known as the Gerber view, and we have ordered it in the JLC PCB Hong Kong. So we would also like to thank them for their quick delivery, low price, and also the quality of the PCBs are great. Now moving on to the experimental results. So in the phase 1 of our project, we have developed a simple health monitoring system based on IoT. So here is the prototype for that particular work in phase 1, and also we can see the dashboard from the ThinkSpeak IoT cloud platform where the health data including the heart rate and the temperature has been displayed. Also, the prototype is capable of showing the real-time health data on the LCD display, as we can see from the image clearly. Moving on, here the testing results has been displayed. So we can see the OLED display has been tested once in a while before the integration with the actual circuit. Then we can see the heart rate display on the serial plotter. Then we can see some of the work done with the PCB. It's not completed, but ongoing work that was done. And then we can see the testing for the heart rate sensor. And here is the belt that we were there is the belt or the breathing sensing system which we were testing, or rather we were working with the Arduino IDE. And on the extreme right we can see the watch, which is actually showing the time, or rather displaying the time from the internet through the NTP port protocol. Moving on. So here is the prototype of our wearable design. On the left, we can see the prototype for the smartwatch. It shows the current time from using the NTP protocol, and when the menu button has been hit for once, it then displays the pulse rate, SpO2 level, and the body temperature. Here we can also see the heart rate sensor integrated in the back side of the watch. Next is a breathing sensing system, or rather to say the belt, which has been made using the piezoelectric sensor, as it is clearly visible from the prototype image, and a node MCU has been used to collect the electrical signals from the uh, piezoelectric sensor and then process it to get the respiration rate. So here how it has been set up uh, in the user's body. It should be wore on the chest to get the proper output, or the desired results. Moving on. So here is the website hosted on the Firebase. By using proper credentials, we can log into the website and visualize the data on the dashboard. The heart rate sensor takes some amount of time to initialize in order to get the proper pulse rate value. The same goes for the respiratory belt as well. It also depends on the skin color, that is the pulse rate. Therefore, the threshold should be set accordingly. The body temperature, heart rate, SpO2, and the respiratory rate is stored and analyzed to detect the evolutionary changes related to COVID-19. Decrease in SpO2 and increase in pulse rate variability can be found to be associated with ambient concentration of fine particles. Moving on. So here is the IoT dashboard from the website. So the yellow curve depicts the body temperature, the dark green curve on the right depicts the heart rate of the user. The pink curve on the left depicts the oxygen saturation level of the user, and last, the dark green curve depicts the respiratory rate of the user. Moving on. So here we come to the conclusion and future direction of our project. In this work, an integrated system has been developed for the detection of some key symptoms for COVID-19. By continuous monitoring, it will be possible to identify the trends in a particular symptom. This can also reduce the last-minute panic and stress for medical treatments. Immediate actions can be taken regarding the isolation of the individual so as to avoid the spread of the disease. The system shows data for different sensor parameters, that is the body temperature, heart rate, SpO2 and respiratory rate. The cost of this device can be comparatively lower than any available fitness tracker. This device will be great useful for the frontline workers. By constant analysis of their health and their body, we can keep them safe and protect the people who protect us. Some features can be added, such as the fall detection, which can be done using a gyro, then sending an emergency alert, then providing the GPS location. This can also be some added features in with the existing system. The respiratory belt is less prone to damage, but some advanced signal processing applications are also required to increase its accuracy to detect psychophysiological condition of an individual. Features can be added using TinyML, which is a machine learning part for low-powered embedded systems, and TensorFlow Lite to detect the anomaly. Optimizing the battery using Bluetooth Low Energy (BLE) and also adding a vibration motor to give a physical feedback. Moving on. So here is the Gantt chart of our project. Starting from the literature review to the problem identification, we have studied various web technologies, types of sensors to be used and microcontrollers. Then we have started working on the sensor modules and IoT hardware and testing its respective inputs and also analyzing its output. After all those work has been done, we started designing the smartwatch using KiCad and also the respiratory belt. Finally, integrated the wearable design with the IoT server to store and display the parameters on the Firebase. So, moving on, here are the references which we have used for our project, further studied and examined various types of already existed health monitoring systems. Thank you. So next, there will be a video shown for the working of the project. Here, the block diagram is divided into two sections. The top one describing the watch and the bottom part describing the belt. The watch works with a 3.7 volt LiPo battery and has a LiPo charging circuit integrated with it. This watch connects to the predefined access point and sends the temperature, heart rate and SpO2 data to the Firebase real-time database. Once the data is stored on the Firebase, we can view the data on the custom web page hosted on Firebase as well. Now, for the belt, it works on a similar principle to the watch. The belt is powered by a 9-volt battery. Once the Node MCU is connected to the internet, the data is sent to Firebase real-time database every 1 minute. Then, later the data is viewed on the custom web page along with the data from the watch. Let's take a look at the demo for better understanding. As soon as the watch turns on the microcontroller, fetches time from the internet and displays it on the watch, which is very accurate and always up to date with the internet time. For this, it uses a protocol called NTP, which stands for Network Time Protocol. It also has two buttons for the user interface, one for reset and the other one for changing the screen on the watch. By pressing the reset button, the microcontroller will reset all the values of the sensor, while the menu button will slide the content of the sensor data to the main display. Now, these data will be sent to the Firebase every 1 minute, which can be seen on the Firebase dashboard getting updated in real time. As far as the belt, it uses a custom-made sensor, which is made of piezo and some rubber bands. This custom sensor will flex according to the inhaling and exhaling of a user. Then this inhaling and exhaling is converted into an electrical signal and sent to a microcontroller. Then further this data is sent to Firebase database every 1 minute over the internet. To access all the data in a user-friendly way from Firebase, we have created a website using HTML, CSS and JavaScript and also hosted it on Firebase. By going to the custom URL, you can visit the website which lands on the login page. Once you have entered the proper credentials, you can see the data from the sensors is plotted in a graph for users to analyze easily. The first graph shows the temperature, the second graph shows the heart rate of the user, the third shows the SpO2 level of the user, and finally the fourth one shows the respiratory rate of the user. This wearable device will be great useful for the frontline workers who are fighting every day, so constant analysis of their health and the body, we can keep them safe as well as protect the people who protects us.